Myself, Wesley Jacob, Assistant Professor, Rogini College of Engineering and Technology. In this video session, we are going to discuss on the subject Theory of Machines, subject code ME3491, Unit 3, Friction in Machine Elements. Now we are going to discuss about frictional forces on screw, or it is also called as screw friction. When a screw is subjected to large axial loads, the frictional forces developed on the thread become important to determine the moment needed to turn the screw. So this slide shows a diagram. The diagram is a screw jack, which is an application of screw friction. Now we shall discuss what is screw jack. The screw jack is a device for lifting loads by applying a comparatively smaller effort at its handle. The principle on which a screw jack works is similar to that of an inclined plane. The diagram shows the screw jack. So the screw jack has thread. So as we know that we have two types of threads, V threads and square thread. In screw jack they use square thread. So here there is a friction between the thread and the nut. So while turning the screw, it will lift the loads, heavy loads. It can lift heavy loads. Now we shall solve a problem in screw jack. I just read out the problem. A 150 mm diameter valve against which a steam pressure of 2 meganewton per meter square is acting is closed by means of a square threaded screw 50 mm in external diameter with 6 mm pitch. If the coefficient of friction is 0.12, find the torque required to turn the handle. In this problem we have to find the torque. So we can see the given datas. The given datas are the diameter of the valve, which is equal to 150 mm, and the pressure is equal to 2 meganewton per meter square, and the external diameter of the thread is 50 mm, and the pitch of the thread is 6 mm, and the coefficient of friction mu value is equal to 0.12. First we have to find the load on the wall, so which is W, which has to be lifted. The load to be lifted is W, which is equal to pressure into area. The pressure is given 2 meganewton per meter square, and we can find the area by using the formula pi by 4 into d square. By multiplying the pressure into area, we can get the load, which is equal to 35,400 Newton. Next we have to find the mean diameter of the screw. So it is denoted by small d. Small d is equal to d naught minus p by 2. D naught refers to the external diameter of the thread, and p refers to the pitch. By directly applying the values, we will get the mean diameter of the screw, which is equal to 0.047 meter. So next we have to find the alpha value by using the formula tan alpha is equal to p by pi d. We can determine the alpha value. Alpha will be equal to tan inverse of p by pi d. We know the pitch and the mean diameter. By applying the values, we will get the alpha value. After finding the alpha value, we have to find the force required to turn the handle. The formula of force required to turn the handle is P is equal to W into tan alpha plus pi. So we can what is pi is the frictional angle. We can find it by the formula mu is equal to tan pi. So which is the coefficient of friction is 0.12. By tan inverse of 0.12 we will get the pi value. So by applying the values in the force required to turn the handle, which is P is equal to W tan alpha plus pi, we will get the value of force 5713 Newton. Next, by the values of the force and the mean diameter, we can find the torque required to turn the handle. T is equal to P into D by 2. By applying the values, we will get the answer 134.2 Newton meter. Next, we are going to discuss about friction clutch. Normally, clutch is used in automobiles. The friction clutch is used to connect the engine to the driven shaft. In operating clutch, it should be taken care so that the friction surface engage easily and gradually brings the driven shaft up to proper speed. So there are the following types of clutch are disc clutch, cone clutch and centrifugal clutch. In disc clutch we have two types, single disc or multi-disc clutch. We shall discuss the types of clutch one by one. The figure shows the single plate clutch. A single disc or plate clutch consists of a clutch plate whose, whose both sides are faced with a friction material. It is mounted on the hub, which is free to move axially along the splines of the driven shaft. The pressure plate is mounted inside the clutch body, which is bolted to the flywheel. Both the pressure plate and the flywheel rotate with the engine, crankshaft, or the driving shaft. Next type of clutch is multi-disc clutch. A multi-disc clutch is shown in figure. It may be used when a large torque is to be transmitted. The inside discs are fastened to the driven shaft to permit axial motion. The outside discs are held by bolts and are fastened to the housing, which is key to the driving shaft. The multi-disc clutches are extensively used in motor cars, machine tools, etc. The next type of clutch is the cone clutch. A cone clutch was extensively used in automobiles nowadays in replacing the disc clutch. It consists of one pair of friction surface only. In a cone clutch, the driver is keyed to the driving shaft by a sun key and has an inside conical surface or face which exactly fits into the outside conical surface of the driven. The driven member resting on the feather key in the driven shaft may be shifted along the shaft by a fork lever provided at P in order to engage the clutch by bringing the two conical surfaces in contact. Due to the frictional resistance set up at this contact surface, the torque is transmitted from one shaft to another shaft. The figure shows the centrifugal clutch. Normally, the centrifugal clutches are usually incorporated into the motor pulleys. It consists of a number of shoes on the inside of the rim of the pulley as shown in figure. The outer surface of the shoes are covered with a friction material. These shoes, which can move radially in guides, are held against the spider on the driving shaft by means of springs. Here the springs exert a radially inward force which is assumed constant. The mass of the shoe when revolving causes it to exert a radially outward force, centrifugal force. The magnitude of this centrifugal force depends upon the speed at which the shoe is revolving. The centrifugal clutch can be also used in automatic transmission between the shafts.